Cool. So now we're going to do some more, and we're going to go to ChatGPT, and we're going to say, we got level of significance, confidence level, visual explanation from the slide. We're going to say, can you please explain for me? And we'll see if we already went through this, because margin of error, interval estimate. Please explain what is an interval estimate. Please explain margin of error and the interval estimate. Please explain for me, and we'll see what this is. Interval estimate of a population mean where the standard deviation of the population is known. So we're going to ask for an explanation of that and see how it explains it. I'm going to take another look at this just from ChatGPT's perspective. Let me break it down. The interval estimate of a population mean where the standard deviation is known. Standard deviation of the population. What is the population mean interval estimate? When we talk about an interval estimate of the population mean, we are referring to the range within which we expect the true population mean to fall based on sample data. I really like that explanation. That works a lot better for me than this little graph here, where you're looking at, they're kind of centering the interval around the population mean. I like thinking of this from this perspective, the sample mean plus or minus some margin of error, and does it include the population mean, right? I understand what they're getting at. I just feel like that's a little bit convoluted. And the way that ChatGPT describes this is the way I think about it. When we talk about an interval estimate of the population mean, we're referring to the range within which we expect the true population mean to fall based on sample data. If the population standard deviation is known, so population standard deviation is known, the estimation process becomes a bit simpler because we have more precise information. Formula for the confidence interval when the population standard deviation is known. The formula for calculating the confidence interval when the population standard deviation is known is the sample mean plus or minus z alpha 2, z subscript alpha 2, times the population standard deviation divided by the square root of the sample size. So this is the confidence interval, right? And this here is the margin of error, right? Because it's the mean plus or minus the margin of error. So x bar is the sample mean, z subscript alpha 2 is a z value or a z score associated with the confidence level, e.g. 1.96 for 95% confidence. Why 1.96? 95% confidence means that, boom, in the middle of the graph, we have 95% confidence. Right here is the 95%, which means our alpha is 5%, and alpha can also be referred to as level of significance, just learning the terminology. And so if we have 5% in each of these tails, we're looking for 2.5% in 5% in both tails, 2.5% in each tail. And that means if this is 2.5%, the rest to the left is 97.5%. And so if we go and we look at 97.5%, which is 0.975, which is right here, that's 1.96. And so the z-score is 1.96. What is z? Z is the number of standard deviations from the mean, right? It's some, like z is how far is something from the mean. And in standard deviations, how many standard deviations is something from the mean? So we're saying at 95% confidence with 5% in our alpha, which means 2.5% in each tail, right? When we look up 97.5% of our data, 2.5% here, 97.5% there. When we look up 97.5%, 0.975, we get a z-score of 1.96, which means that 1.96 from the mean go out 1.96 standard deviations, and this is where you're going to have from this point over 97.5% of your data. Right? And we're really interested in that 1.96 because when we need to go 1.96 standard deviations gives us this point, right? 1.96 times our standard deviation, so almost like 2 times the standard deviation gives us this point, and negative 1.96 times 2 standard deviations gives us this point. So that gives us our interval estimate or our confidence interval. Okay, so let's keep going, ChatGPT. This is sigma, lowercase sigma is the population standard deviation. Lowercase n is the sample size. And the population standard deviation over the square root of n is the standard error. It's the standard deviation of the sample mean. No, it's just the standard error. It's the standard error of the mean, right? The amount of variability in the sample mean. Yeah, the sample mean. So it's the standard error or the standard deviation of the sample mean. I don't know why you're dividing by the square root of n on that one. Higher level than my pay grade. Steps to calculate the confidence interval: find the sample mean, determine the z-value based upon the confidence level you want, 95% or 99%. Common z-values are 1.96 for 95%, 2.58 for 99% confidence. And we saw that here, right? 2.576 for 99% confidence, or for 2.58. 2.58 there, 2.576, you round that up to 2.58. And we saw how to look these up. And then calculate the standard error. And so standard error is going to be standard deviation over the square root of n, and then you multiply it by number of standard deviations. I think the standard error would include both of those. This tells you how much variability there is in the sample mean. And multiply z-value by the standard error. This will give you the margin of error. That's what I was looking for. So you have your standard error and you have your margin of error. And calculate the confidence interval. Add and subtract the margin of error from the sample mean to find the lower and upper bounds of the interval. This is like a good recipe, step by step, to do it. Example, let's say we have the following data. The sample mean is x bar equals 100. Population standard deviation is 15. The sample size is equal to 36. And the confidence level is equal to 95%. So let's just take this, copy it, and we're going to go over here. And then we're going to duplicate this slide, which means I got to come back over here and copy this again. And on the slide, I'm just going to take all this stuff out. Bam, boom. And I'm going to put in a text box, which is not that. Cancel. And text box is, where are you? I could just actually go up here and I could go to slide and I could apply a layout. And I want, what do I want for the layout? I want like just 2 text boxes, which is like that one. And I'm going to choose both of these and I'm going to make them like, I don't know, 18. We'll see if that works. So now I'm going to click away from them, click in it, and then paste my stuff in there. Ooh, that's messy. I'm going to paste it in like that. That's better. That's great. I like that a lot. And I'm just going to take this out. And then I'm going to bring this over here and paste that in so I get the same text over there. And then here I'm just going to do my calculations here. That's looking good. I'm just going to take that out and just do it like this. Okay, so the first thing I want to do is I have a 95% confidence level, 95%, right? So I'm going to figure out how many Z's is that? What's my Z score? So 95% confidence level means that here, 95%, which means my alpha, or my level of significance, right? Level of significance, I could see that right there, level of significance, is 5%, which means 2.5%, 2.5%, 95%. So this is 2.5% here. That's alpha divided by 2. It's 97.5% of my data. If I go here and I look for 0.975, I get 1.96. And so 1.96, going back to this last slide here, is that it? No? Where'd I go? Where'd my slide go? Just a second, I gotta find my slide. Unknown, I thought we did it there. Maybe I did it all the way down at the unknown. That's not it. Hold on, I gotta find my slide. All right, I found my slide. So confidence level 95%, Z is equal to 1.96, right? Like that's my Z that's for alpha divided by 2, right? I mean, we know all that. I don't need to put that in there. All right, so now I've got my confidence level, and now I need to calculate my margin of error, okay? And so my margin of error is going to be this formula. And let's just find my previous calculation. We'll copy that. And then we'll come back here and we'll paste that in. Boop. And we'll bring that like right here, right? And we'll draw a little arrow from there. Give me my arrow. And we'll draw an arrow from there. And then we'll also draw an arrow just for fun back to this calculation. That looks like it's a little bit too much. And then we'll calculate in here our margin of error. And so we have Z 1.96, 1.96, 96, and that's going to be multiplied by standard deviation, and our standard deviation for the population is 15. 15 divided by the square root of the sample size, which is going to be 6. Okay, and that's going to be equal to 1.96 times 15 divided by 6 is equal to 4.9. So we're going to do 4.9 equals 4.9. And I just remembered that it's Friday night. It's 5 o'clock. I'm going to share something. California lottery. I saw this today. I've got like one vice. And it's just like, it'd be so amazing if you won like a huge lottery. Just like, because you could, ends at 7:45 p.m. So it was like 740 million. I was like, I want to buy a lottery ticket. So I'm going to try to make it somewhere where I can buy a lottery ticket before 7:45 p.m. So there's our margin of error. And so then our confidence interval, which is also known as what? Confidence interval is also known as the interval estimate, right? Confidence interval, aka interval estimate. And that's going to be equal to, it's going to be our sample mean, which is going to be our sample mean. That really kind of came through kind of funny. Our sample mean, we're just going to say x, we're just going to say it's equal to 100. And sample size, that kind of came through funny too. And this one came through funny also. We'll get rid of that. And so that looks better. So that's going to be equal to our confidence interval is going to be 36 because that's our sample. No, that's our sample size. We need our sample mean. It's going to be 100 is the sample mean. Is that right? 100 seems like it should be. Sample mean is 100. And that's going to be 100 plus or minus 4.9. 4.9. And so the interval will be, I don't know, what is that, 95.1, 95.1, 95.1, and we'll do that, and that, 95.1, with plus 4.9 is 100, right? Yeah, just checking that. And then that's going to be 104.9. So with 95% confidence, based upon the sample that we did and the sample mean that we got, knowing our population standard deviation, with 95% confidence, the population, the estimate we have of the that we got through our sample, the sample mean that we got through our sample, with 95% confidence will include the population mean. So the population mean will be between, with 95% confidence, will be between these two values. So, it's a lot, but you could see how, like, hey, if these were lottery tickets, and we could say with 95% confidence the numbers are going to be between here, it's like, let's buy up all those numbers between 95.1 and 104.9. Like, that's high level of confidence, 95%, so that's kind of like how it works. So that's another example of doing the interval estimate of a population mean. Let's see what else ChatGPT says. So here, find the sample mean. X bar is equal to 100. Value for 95% confidence is 1.96. Standard error is 2.5, and that's 15 over 6. Did we get 15 over 6? We got 15 over 6. And then our margin of error is the z score, the number of standard deviations times the standard deviation or the standard error. And then we have our confidence level, and so standard error is standard deviation for the sample. And then we have our confidence interval, which is going to be the sample mean plus or minus the margin of error, which is that. And so our confidence interval is 95.1 to 104.9. 95.1 to 104.9. Conclusion. When the population standard deviation is known, the interval estimate provides a range of values within which we expect the true population mean to lie with a certain level of confidence. In our example, we are 95% confident that the true population mean is between 95.1 and 104.9. This method is more precise when standard deviation is known because it uses the actual population standard deviation rather than an estimate from the sample. Thumbs up. All right, that is another example of getting an interval estimate of a population mean when the population standard deviation is known.